In this video, I'm going to explain ionic bonding. It is one of the types of bonding that you have to learn as part of chemical bonding. I'm going to give you the definition of ionic bonding. I'm going to explain the kind of elements that are involved in ionic bonding. Then I'll end with illustrating how ionic bond occurs. Now, let us go to the definition. I want to emphasize here that the definition that you use depends on your syllabus. So follow what your syllabus is saying about ionic bonding. It is also called electrovalent bonding. You may find that in other textbooks or in other videos, they will be referring to it as electrovalent bonding. It is one and the same thing, but I like using ionic bonding for a certain reason. This bonding involves the transfer of electrons from one atom to another, and I just had to highlight here that the transfer is actually from metallic atoms to non-metallic atoms. So if I give you two elements and I say they are involved in ionic bonding, you should know that the metallic atom or the metal is going to donate electrons to the non-metallic one. And so this is very important. It involves metals and non-metals. Very key here. If you have forgotten about this, go to the video where I explained why do atoms bond. They do this to achieve the electronic configuration of the noble gases. So for atoms, for metals, it is actually easier to lose or to donate the valence electrons to another atom or to another element. It is quite easier to do that than to gain. So the metals are going to donate their valence electrons, and the non-metals are going to receive, or they're going to gain those electrons into their valence shells. And I want to end by saying, once there is this transfer of electrons, remember electrons are charged particles. So if a neutral atom loses two electrons, it is going to have a net positive charge. So metals, when they lose these electrons, or the non-metallic atoms, when the metallic atoms lose these electrons, or when they transfer these electrons, they form positive ions, what we call cations. And the non-metals, or the non-metallic atoms, they gain the electrons, they become negatively charged, they form what we call anions. This is very important. So the ionic bond itself is essentially an electrostatic attraction. In electrostatics, we say that opposite charges attract. So during ionic bonding, there are going to be opposite charges formed here. The positive charges formed by metal atoms losing electrons, and the negative charges formed by non-metals gaining electrons. Then there's going to be a force of attraction between these positive ions and the negative ions. And that is the ionic bond. Very, very important here to illustrate that the bond is about the electrostatic attraction between oppositely charged species. In this case, positive ions and negative ions. This is the definition of ionic bonding. Very, very important for you to understand all the important things that I mentioned now, from the transfer of electrons, from the fact that we have metallic elements or metallic atoms and non-metallic atoms involved, and also to the fact that we're going to form ions which are oppositely charged and they therefore attract each other. Now let me illustrate electrovalent bonding or ionic bonding with an example. I'm going to illustrate this with an example. I'm going to use the formation of the common salt, sodium chloride. It's a very easy example. If we are forming the common salt, sodium chloride, from the name sodium chloride, it means we have two elements here involved. One of them is sodium, and A, and the other is chlorine, Cl. Now, I'm just going to draw the the Lewis diagrams of these two. So Chlorine is in group 7. It has 7 valence electrons. I'm going to use X's for its electrons. This is chlorine. And sodium is in group 1. It just got 1. It has 1 valence electron. 1. Let us use this dot to represent the only valence electron on sodium. Now, sodium can easily become like neon by losing this electron. So it can give it away. And it can give it to chlorine because chlorine actually wants to have an extra electron for it to have the electronic configuration of argon. This is the basis for ionic bonding, guys. As long as you understand that when this kind of bonding is occurring, all these atoms, they want to achieve the electronic configuration of the closest noble gas. If you get that in your head, you'll just be cruising through. Now, so we're going to have this electron here migrating to chlorine. So chlorine is going to gain the electron and sodium is going to lose the electron. So if sodium loses 1 electron, it now has got a net positive charge. It has now extra positive charge. Now it forms Na plus. So this forms Na plus, which is an ion. And chlorine, because it has gained 1 extra negative charge, is going to be Cl minus. This is what we have. Because these two are oppositely charged, what happens is they now attract each other. So there's a force here of attraction. This force of attraction is an electrostatic force of attraction. It's actually a very strong force of attraction. So the ionic bond is actually a very strong bond. So from here, we're going to have NaCl minus. This is now our sodium chloride. The sodium chloride is neutral because these two, the negative charge and the positive charge, have got the same magnitude. They are going to cancel each other out. And so we have a neutral substance called sodium chloride. It is called an ionic substance because it contains these ions, the sodium ion and the chloride ion bonded together. This is how it happens. I can also illustrate maybe magnesium oxide, the formation of magnesium oxide. In magnesium oxide, we've got magnesium, Mg, and we've got oxygen. Magnesium is in group 2, so it has got 2 valence electrons. This is the Lewis diagram of magnesium. Then oxygen is in group 6. It has got 6 valence electrons. So we have here, just going to use this, 6 valence electrons. Let us look at the desires of these two atoms. Magnesium can lose these 2 electrons and become like the previous noble gas, which is neon, whereas oxygen can gain 2 more and also become like neon. So oxygen wants or desires to have 2 more electrons. Magnesium does not want the 2 electrons, it wants to give them away. So magnesium is going to be the donor. So in all this ionic bonding, the donors are the metals are the donors, the nonmetals are the recipients. So the nonmetals are receiving the electrons that have been given up by the metals. So we're going to have a migration here, the atoms coming here, the electrons coming here, such that in the end we have Mg 2 plus and O 2 minus. Please see how I'm writing the charges here. We don't say plus 2, we write 2 plus, 2 minus. Now these now can come together because there's now a force, electrostatic force here. There's an electrostatic force. They attract each other, so they form one compound called MgO. That's why it's written as MgO, magnesium oxide. this is how it happens. Maybe I should just give one more examples with calcium fluoride. I'm just going to use calcium fluoride. Calcium fluoride. Calcium fluoride. So from the name, we know that we have two ions here, the calcium ion and the fluoride ion. So how does it start? We go to the starting point. The starting point is a calcium atom and a fluorine atom. And the fluorine atom is in group 7, so it has got 7 valence electrons. Whereas calcium is in group 2, it has 2 valence electrons. Calcium wants to lose these ones so that it can become like the previous noble gas, which is argon, by the way. And fluorine wants to gain 1 electron there so that it becomes like the next noble gas to it, which is a neon. So there's going to be a migration here. So calcium has got 2 that it wants to lose. So one goes here, obviously, but there's another one left. So in this case, we're going to have 2 fluoride ions. So we're going to have another fluorine atom coming here with its 7 valence electrons. Then, so one of the other electron will come here. In the end, we're going to have 2 fluoride ions and 1 calcium ion. So we're going to end up having Ca2 plus and 2 F minus. This is what we have. So these are going to come together to form a compound called calcium fluoride. Now the formula for calcium fluoride becomes CaF2. This is why we write it as CaF2, because we need 2 fluorine atoms here to receive. Each is going to take 1 electron that has been given up by calcium. Guys, this is how ionic bonding occurs. This is how you can illustrate ionic bonding. Thank you for watching the video. If you have any comments, write in the comment section below. Subscribe to the channel, give a thumbs up to the video, and share it with your friends. Thank you.